Kia ora. Hello from wherever you're dialing in from, around New Zealand or Australia. I'm Michael Grice. I'm one of the RTSA New Zealand chapter committee members in Tamaki Makaurau, Auckland. First of all, I want to thank you for coming along this lunchtime. The RTSA are a trans-Tasman organisation for anyone with professional interest in the railway. We aim to provide technical topics of interest, support business in the railway industry, and support the continuing professional development of its members, as well as promote close working relationships between railway participants. We hold regular face-to-face CPD events, webinars, training and education, awards, knowledge bank conferences, you name it, we got it, all under the rail umbrella. We always welcome new members, so if you wanted to join, go to our website, maybe flick a slide over, please, mine. Yeah. Head to rtsa.com.au and get all the information you need. And we'll be a proud sponsor at Core this year. What's Core? It's the biggest event in your social calendar. And if you've not got a ticket, what are you doing? Get yourself there. We've got subjects from narrow gauge to standard gauge, high angle crossings, requirements management, you name it, we're covering it. And if you're still on the fence, I can confirm that the dudes will be there. That's right. John Garner, Mark Gallery, Mark Breslin, and Daniel Hedefin, the RTSA dudes, will be performing on the night. So get yourself there. Right, on to the main event. So today's presentation is on station access, pedestrian movement, customer experience, presented by Martin Pete and Louise Hamilton from Stantec. Martin is a practice lead for pedestrian modelling and has been enhancing the station access and customer experience at rail stations across the globe. Louise is a senior landscape architect and an internationally certified CPTED practitioner. This presentation will discuss the application of CPTED principles, why they're all fundamental to design is safe for transport hubs and their physical surroundings. I'll now pass you over to Martin.
Thank you very much. Through today's presentation, we're looking at designing spaces for the people that use them, and we'll take two different angles looking at this. To begin, I'll step through the application of pedestrian modelling in station design and look at lessons learnt from a couple of case studies. Station modelling and simulation comes at the intersection of station design, patronage numbers, and the passenger experience, with all three intrinsically linked. Typically, we'll be involved during the early stages of design to inform layout decisions, optimize circulation, and space-proof the areas. In stations, this includes new builds and redevelopment, improvements to accessibility, catering for increased ridership numbers, changes in service frequency, and rolling stock. So we take a performance-based approach to passenger movements, and this is often prescribed through functional requirements. We want to understand the levels of service and metrics, and this includes accessibility, such as the difference in route lengths for step-free access. The passenger modelling provides a useful tool for stakeholder engagement, and this is by demonstrating visually how stations can operate under a range of conditions and interface with the surrounding transport network and the urban realm. The area of influence often extends beyond the station to include pedestrian routes on the last mile, be it from other transport modes or integration with the surrounding network. So why modelling? It provides more planning and design certainty, allowing projects to progress forward, and can have benefits in value optimization and cost reductions. Improving stakeholder engagement and integration becomes part of it, and through this, we can demonstrate operational benefits and understand the impact of service disruptions. One of the useful elements is being able to quantify footfall, and this is important for both customer level service, and we can also demonstrate commercial value for the likes of station retail and oversight development. And we've used this in the past to assess developer contributions. So our approach to station modelling is typically around understanding the population and the user groups. So developing the demands and understanding the pedestrian flows. Who's using the station? How many people are there? What are the peak times and where do they come from? Walking, cycling, park and ride, and other public transport services. An analysis in the early stages is normally used to size key internal and external elements and space-proof the design. As we increase the level of analysis, we can develop simulation models which demonstrate visually the movement through the station, circulation, and interfaces with the surrounding area. And through the various levels of service, at a project level, technical requirements are specified in terms of level of service for each portion of station infrastructure, and this dictates or influences the passenger experience and safety. And a caveat here that levels of service requirements are often calculated in terms of passengers per minute, and particularly with lower train frequency, how this minute is defined can be open to interpretation. So that's been one of the key findings through a number of projects. Analysis is focused around key station elements that have a direct impact on the customer journey, and criteria for each component and then the combination of these lead to the individual customer experience. Scope and technical requirements for these are covered through technical guidance and station modelling parameters. And for example, in Auckland, the Transport Design Manual includes technical requirements for station infrastructure, and internationally, London Underground's led the way in developing standards, with most jurisdictions have some form of guideline. I've got 3 case studies today, and the first is for a light rail station under the road corridor. And here a constrained footprint led to multiple iterations of the vertical transport layout with an objective of understanding how the station performance varied in each, and the connectivity between ground level and the platform for all the users, including those with mobility needs. So here 2 different options are presented, option 1 on the top and option 2 below, with different escalator configurations for each alongside the set of stairs below. And each of these has had a different operational impact, including on the platform utilization and how people were distributed. At the street level, we needed to understand the walking catchments of the station entrances and the locations of the bus services, as this dictated the movements down into the station. What we found for the top option was that it had the longest distance travelled from platform level to the south entrance, and this was in part due to the orientation of the escalators, creating a 180 turn at both the platform level and the concourse level for all the users using those escalators. The second option had the shortest distance travelled, and because of the orientation of the escalators, but this also meant that at platform level, operational flexibility was limited, given the proximity of the escalators to the entrance, and also down on the bottom right, the proximity of the base of the escalators to the lift bank behind. And across all the levels, we wanted to understand the difference in access to the platform between lifts, stairs, and escalators. And this work demonstrated the criticality of maintaining runoff areas at each of the levels around the vertical transport. Through the work, we developed a simulation model of the station, and so the next slide has a video that moves through the platform to concourse and then street level. So the simulation model captures all levels of the station as people move from the platform up the escalators, through the concourse, and out into the entrances. And likewise, people moving the other direction from street level down to the platforms. Here we're able to observe and quantify the queuing at the escalators, platform clearance times, and cross flows of desire lines. and the relationship between the elements within the station. The model provided a useful tool that was used to compare and contrast different options as the design detail evolved, with the aim of reducing costs for the infrastructure while enhancing the customer experience. The next case study I've got comes from overseas in Canada, and just south of Toronto is Oakville Station. So this station has a daily patronage of about 14,000 people, and it's a commuter station to the southwest of Toronto. What we're looking at here was demonstrating the local station planning guidelines and the pedestrian modelling guidelines, which we were involved in developing. And here we were looking at the redevelopment of the interior of the station and incorporating an ancillary tenant, a cafe with significant pedestrian activity. So from the outside of the station, it was important to understand the mode split, be it the park and ride demand, public transport transfers to the bus station on site, walking and cycling connections. The current conditions had about 80% of passengers entering from the main entrance and 20% coming from the bus terminal. And this came from the mode split at the station. We were looking at changes to the concourse area and adjusting the number and the location of the entrances inside to redevelop that space. So this is a look. The top right shows a schematic of the station building itself, and the data that we had was captured from existing tag off, tag on data, which helped us to understand the current station patronage and the peaks. We were also able to project this forward to 2040, which was our design year, with a 80% ridership growth forecast. Typically, through a lot of the station guidance, we would be looking at the AM peak and then taking an inverse for the PM peak. However, in many cases, and this is one of the lessons learnt here, the morning peak is primarily boarding, whereas the PM peak is more spread and has a higher mix of boarding and alighting. And in this case, the PM peak generated higher two-way movements. Through the redevelopment work, we wanted to look at closing the entrance out to the bus terminal and putting everyone through the main entrance of the building. So here we were looking to rework the internal space and reprogram that top space for a cafe function. In order to do this, we needed to quantify the passenger levels of service through the area and calculate the corridor width that would be needed through the station building to keep as clear space. One of the things that we found were looking at the boarding and alighting demands, and this is shown in the graph, is how dominant the alighting demands in red are and how peaky they are after the train arrival. And this meant that on average, demand is low, but there's high peaks with two-directional flow occurring as there's low levels of boarding, but a big alighting load. And the variable levels of service here highlights the importance of defining the minimum requirements for levels of service, how it's calculated, the time period, and how lengths of time with no passengers are treated. And so the peak minute here looks at during those key alighting periods, whereas the average minute is spread over a 15-minute period and really emphasizes the different metrics and different ways of interpreting levels of service. A secondary task was to assess the food and beverage offering and identify how much space was needed for queuing there. And combining that with the clear width needed through the station allowed us to influence the design. So this example demonstrates the need for localized data to inform the analysis and an understanding of train service patterns and future growth. And then we're able to develop a plan of how to maximize the internal footprint. My third case study is taken from Brazil, and this is at Deodoro Olympic Park, which is located on the main rail line outside Rio, where a series of venues were co-located. And the main access to this series of venues was through a single rail station. This is an aerial view capturing some of the venues. The train station is located to the bottom right of the screen. And here we see the hockey venue, and out to the left is the rugby sevens. So these had capacities of 7,000 and 15,000 spectators respectively. And the key part of the getting people away at the end of the day back to the train station was egress, often with events having finish times that coincided. So that's a large number of people to get away to the station and out back to the city centre. So Villa Militar Station has a side platform and an island platform. With the city-bound platform being on the northern side, we're able to facilitate direct access onto the platform from the venues located to the north. So through the planning and operational phases, we're able to firstly make a plan and crowd model the people leaving the venue. So coming out down the dots representing individual people moving. And here we needed to understand the station demands from the venues and also the station operations. This included the line loading to understand available capacity that would come through on each individual train. From here, we were able to work out how to load the platform within the headways between trains. And this included access to the platform and staging of spectators using holding pens to match the capacity. These simulations were essential in the stakeholder engagement that we needed to do, the local landowner, local councils, and the rail operator. And the tools that we developed and presented, we used to help train the venue teams in how the operation would work. One of the neat things about this was seeing it live and in operation, and the success of the system and the plan that was developed through the crowd modeling and design of the station operations. So here we see videos of people being held in pens and then released through as trains arrive and capacity becomes available on the platform. And this operation repeated night after night during the period of the games. So through this work, a number of lessons learnt, primarily the importance of local calibration of the parameters, acknowledging that not all stations perform the same, needing to look at the nuances and individual station-specific inputs, such as boarding or lighting platforms and how people spread along the platform. At existing stations, the splits between ramps, stairs, and lifts can differ depending on the demographic of the users, the number and location of station access point, train stop location along the platform, and the location of access modules compared to other parts of the station precinct, and where that last mile routes come in and the different modes. In a similar manner, growth in the number of passengers and the rolling stock, so longer trains, can also lead to an increase in emergency evacuation requirements and a need for additional vertical transport. Further afield, last mile factors include interchange time and distances. So understanding the location of bus stops, bike storage, and car parking influences access to the station platforms. One thing that we're finding is the importance of passenger composition and the significant influence that that has on station operations and performance. Typically, we use around 8% people with restricted mobility to cover a variety of mobility needs. However, we are aware that globally and in New Zealand, there's an aging population, and research out of the States suggesting that in excess of 12% of people might have difficulty using the stairs, and 22% having some form of accessibility need. So to conclude, station modelling is most useful when considered early, which means scenarios and layouts can be tested, different permutations tried, and we're able to design for the end user. And on that note, I'll hand over to Louise.
Thanks, Martin. That was a great presentation. I am Louise, a Senior Landscape Architect and Crime Prevention through Environmental Design Practitioner. So I've recently completed assessments on urban design projects, bus terminals, and a railway station upgrade. So what is CPTED? Problem seeking before problem solving. CPTED covers a wide range of crime prevention strategies. The following presentation will focus on station design and the transitional environment to railway stations. When undertaking a station assessment, 4 main questions should be asked. What are the assets, persons, places, information or property that require security protection? What are the criminal or other threats, street crime, terrorism and or sabotage against which the assets must be protected? What are the vulnerabilities of the assets? What are the countermeasures required to mitigate the threat? In the midst of project demands and deadlines, sorry, the screen's not taking over. In the midst of project demands and deadlines, it is important we remember, excuse me, that not everyone we design for is like us. This is a typical commuter scenario for a range of people within our community on any given day in any given part of the world. There is a range of people from different backgrounds and have different physical and cognitive abilities. It's a normal night and each of these people are taking a short walk through a well-lit park to catch their train home. Let's call the man on the bench Dave. He is dressed in dark clothing and you don't know who this man is, how he is feeling, if he is just taking a rest or has concealed weapons and a criminal agenda. There is pathway lighting, but also dense adjacent vegetation and a lot of shadow which creates numerous concealment areas. It is important to pay attention to your surroundings. I'd like you to take a moment to cycle through each of these images and put yourself in the shoes of that person and how you would feel moving through this space. Imagine you are each of these people. How safe would you feel with Dave sitting on the bench, a potential threat to your safety? Oh, shoot, sorry. How much attention were you paying to your surroundings? Did you notice the real danger in the background? David just stopped to tie his shoelace. CPTED is identifying risk during the design phase to mitigate danger in the built environment. Natural surveillance is a CPTED concept directed primarily at deterring illegitimate users from environments for the fear of being seen and identified undertaking illegitimate behaviour. Natural design, street design, landscaping, lighting, neighbourhood design and site layout all influence the capacity for natural surveillance. The provision of natural surveillance helps to create environments where there is plenty of opportunity for people engaged in their normal behaviour to observe the space around them. Areas can be designed so they're more easily observed through design and placement of physical features to maximise visibility. This includes building orientation, windows, entrances and exits, parking lots, dumpsters, walkways and landscape features, permeable fencing design, location of persons and activities that maximise surveillance opportunities, and minimum maintained lighting standards that provide for clear nighttime illumination. Streets for Girls is a concept focused on creating urban environments where women and girls feel safe and empowered to move freely and participate fully in public life. This involves addressing safety concerns related to street harassment, violence, and lack of access to transport, employment, and recreation. University of Queensland studies show that 1 in 2 women do not feel safe walking alone at night, and that young women are frightened for their physical safety. Recent media has highlighted that many women feel unsafe about or avoid nighttime or early morning outdoor exercise, which poses potential health and wellbeing implications. Feeling unsafe in public spaces at night is not exclusive to women and girls, but there is focus on this group because of the alarming statistics around women feeling unsafe and because of their vulnerability. Simple design modifications, such as more people, lighting, less noise, more security cameras, and less vegetation would make this group feel safer in public spaces. Areas can feel warm and welcoming with art installation or nearby cafes providing good passive surveillance and suitable lighting styles. It is critical when undertaking public space design that we think of the end users, which aren't always like us. These images are of an existing train station where several unintended entrapment areas were found in multiple locations. Reading from left to right, the opaque partition screen layered with large graphics of the station shelter prevents passive surveillance into and out of the seating area. This has created a dangerous concealment area where legitimate users can be attacked without being seen. An electrical cabinet is located in the center of the waiting area. The solid partition allows illegitimate users to conceal themselves and ambush legitimate station users. The underpass on the right has rounded corners which limits concealment areas, but the absence of convex mirrors prevents legitimate users identifying potential threats in the tunnel. It is impossible to see who is in the tunnel until you have a direct sight line at the bottom of the steps. Even then, you cannot see people entering the tunnel from the other entrance. An obvious solution for infrastructure placement is not always the safest. These cabinets have been installed directly in pedestrian accessways or directly beside them. All of these structures are large enough for illegitimate adults to fully conceal themselves and ambush unsuspecting station users. The security fencing creates an additional mechanism for further entrapment in this instance, as it creates another barrier for escape. Locating the structures within the gardens with the door opening parallel to the footpath or fencing would mitigate this hazard. The lights at this train station are connected to the street lights, which come on approximately 6:12 p.m. after dusk. The lighting came on 10 minutes apart on opposite sides of the train tracks. The lack of independent security lighting created a hazard for station users through a lack of clear sight lines and low light conditions, particularly those with low visibility. Both the car parking and footpaths were poorly lit. Parking facing into the station had their own lamps. Street-facing parking was lit by the street lamps, which did not adequately or safely illuminate the space. The absence of an intentional lighting design created concealment and ambush areas throughout the car park, particularly besides vehicles, fencing, and vegetation. Station lighting should run on its own circuits with a backup system. The light should be turned on prior to dusk, ensuring clear visibility is maintained for station users 24/7. The cumulative height of the vegetation lining the station accessway exceeded 6 foot. There was enough density to create multiple concealment and ambush areas. This could have been mitigated by a more tailored planting approach, ensuring the use of low-growing or staggered vegetation only. This is the image on the top right. Inappropriately used vegetation beside pathways create concealment and ambush areas. Vegetation beside pathways should maintain clear sight lines between 700 millimeters and 2 meters from the ground. Unmaintained landscape areas with vegetation encroaching over the footpath create trip hazards. Planting should always be specified in accordance with the site conditions and constraints. Unresolved areas within the built form create opportunity for antisocial behaviour such as graffiti. Increasing sightlines, surveillance systems, and access control would mitigate this behaviour. This is an example of a connecting pathway from a residential area to a train station and is well used by the residents during the day. The project scope included an upgrade to the entry of this pathway as it connects to the train station, but not the remainder of the path as shown in the images. The project scope included an upgrade to the entry of this pathway as it connects to the train station, but not the remainder of the path as shown in the images. Wider connections to projects are just as important as the projects themselves. As you can see from these photos, this pathway has insufficient lighting and overgrown vegetation, impeding light splay and creating shade and shadow. The shade allows moss to grow, therefore creating a slip hazard. The shadow creates numerous concealment and ambush areas along the pathway. It was recommended the local council either decommission the pathway or include it in scope to ensure users are not being put at unnecessary risk by design. Despite this being an architecturally award-winning bus terminal, it now has a strong local reputation for being an unsafe transport hub, which has become a deterrent for legitimate users wanting to avoid being the victim of crime. These are the unintended consequences of the facility not having undergone a CPTED assessment. Council data shows patrons are typically school children, low socioeconomic people and tourists, despite being in the CBD and should ideally be servicing central city workers. Several bench seats are located on the footpaths outside one of the main entrances. These are intended as a waiting area for tourist coaches. It has become a gathering area for youth after school and homeless people who then harass passers-by for money. The ground is covered in litter, spilled drinks, and broken glass. The unintended consequence of this design is a reduction in the perception of safety for legitimate users. The internal waiting area is closed daily between the hours of 2 p.m. and 6 p.m. by the terminal security guards due to loitering, loud antisocial behaviour, and damage to property. The internal walls provide privacy for antisocial behaviour due to the lack of passive surveillance from the outer terminal area. I found 2 main entrances where a vehicle would be able to mount the curb at speed and barge through the glass doors. Once inside, the floor and seating layout has sufficient width for a vehicle to drive at speed into people and exit the building again. Seating placement should be a main consideration with all public space design. In this instance, the seating had an approximate 2-metre thoroughfare between the adjacent wall and the back of the seats. The seating was facing all the bus boarding exit doors. This exposed patrons' backs to the wall, making them feel vulnerable from attacks from the thoroughfare behind them. Movement design analysis would have identified this risk. This particular train station is also notorious for antisocial behaviour and has responded with a heavy surveillance presence. The extent of the building is covered in either fixed or pan tilt zoom cameras. Despite this layer of protection, surveillance systems should be considered a support mechanism only for considered CPTED design. Often surveillance systems are recorded but not actively monitored, so there is a delay between the observed crime and the first responders attending the scene. At this point, harm to legitimate users has already occurred. While surveillance systems are a mild deterrent for illegitimate users, they do not prevent crime and should be considered a last layer of defence. The likelihood of a specific building being targeted for terrorist activity is generally difficult to predict and not entirely common. The risk of a CBR attack persists globally and should be accounted for during design. No building can be fully protected from a determined individual who is intent on releasing a CBR agent. This is a very high-level list of items to determine how protected your building is in the event of a CBR event. If you are designing a high-capacity station, it is recommended a thorough CBR assessment is undertaken. Zoning design is accomplished through the use of different forms of access control. Think security layering, as though you're peeling layers of an onion. Facility access control should be determined in conjunction with the client and the architect. The design of unrestricted zones should encourage persons to conduct their business and leave the facility without entering controlled or restricted areas. Unrestricted zones can include waiting areas, cafes, bike storage, and certain personnel and administrative offices. Controlled zone movement requires a valid purpose for entry, such as staff areas and security rooms. Restricted zones are areas limited to staff, assigned to areas that require additional access control, such as mechanical areas, electrical equipment, and hazardous goods. Once circulation patterns are successfully resolved through security zoning, physical security systems such as mechanical surveillance solutions can be considered. This proposed train station waiting area is a graphic representation for a project that is currently in the design phase. The glass walls allow visual permeability and passive surveillance. However, there is only one access point at each end of the shelter, which creates an entrapment area if the access points are blocked at each end. These openings measure at 1.2 metres wide. It was found during a CPTED assessment of this project that the waiting area could be blocked by illegitimate users and entrap the legitimate users inside, creating an opportunity for antisocial behaviour or terrorist attack and harm to those inside. An alternative layout to the design, an alternative layout for the design shelter was proposed as shown, where additional access points have been created, which allows better pedestrian permeability throughout the structure. This layout decreases risk of ambush, antisocial behaviour, or terrorist attacks for legitimate station users. Rail transportation has joined the list of what is considered critical infrastructure and is one of many known terror targets. This list is compiled by train, carriage, and station attacks over the last 20 years. It is not exhaustive. The numbers shown here are only some of the extent of injury and fatality that has occurred in public rail transport systems. The sad fact is that most emergency plans prepare for a response during or after an attack has already occurred. Very few critical infrastructure and protection models are available for anti-terrorism prevention. This is why applying CPTED principles such as controlled zone movement, security layering, space hierarchy, infrastructure protection, access control, and defensible design should all be incorporated into train station design. Since different hazards have conflicting requirements on a facility, it is important to know and understand potential design conflicts. Conflicting demands can result in an unintended lower level of protection. Know your political support. Most communities have learned that success of good design hinges on political backing. Seek community acceptance and support through clear communication and engagement strategies. Community buy-in is critical for project support and success. Cost. Engage technical experts from other disciplines early. Save design budget through early communication, avoiding rework late in the project. Know your available financial resources. Is the client funding this project aware of all design implications prior to inception? Are their expectations realistic relative to actual requirements? Are you familiar with governing legal authority documents? Are you aware of the whole cross-section of people that your design will affect? Are you aware of the existing environmental sensitivities, and do you know how to respond to that? Do all relevant disciplines know they should be involved? We don't know what we don't know. Reach out to other disciplines for feedback early. Is the client aware of lifetime maintenance and operation costs? Be organised and involve other disciplines from project inception. Rush design close to deadlines creates a missed opportunity to capture undesirable outcomes for the end user. Short-term cost-saving solutions can create long-term unnecessary expenditure. In closing, we cannot predict what happens within the environments we create, but we can make conscious decisions to mitigate risk for the people we're creating those environments for. Thank you.
Oh, thank you very much, Louise and mine. Two excellent presentations, and yeah, you've got the audience throwing in some questions to you. So start off with what kind of software do you use for your station modeling?
There's a number of different software packages that are available, and personally I'm using Legion and Mass Motion software, so commercial software packages.
Thanks, mine. And excuse me, in your experience, how would you assume all the proportion of different users to cater for people of all ages and abilities?
So ideally, we'd be looking for survey data at an existing station or at a similar location on the network. And this could include counts of people using stairs, ramps, or lifts. And it could be by means of video footage if that was available. And in lieu of available data, there are some other sources. For example, Transport for London have guidance for a range of station types, and this includes the likes of wheelchair users who would always use lifts and can't use stairs or escalators, people with permanent or temporary physical mobility impairments, so the likes of walking sticks or guide dogs that would have a preference for lifts but can use stairs and escalators. And then we look at things like people with heavy luggage or large luggage, and adults with young children who may or may not have a pushchair, and most of those would have a preference for lifts, but they could use stairs and escalators. And so TfL gives a range of percentages depending on the type of station.
Oh, thanks, Martin, for that comprehensive answer. Do pedestrian modelers interface with human factor specialists while making judgments on human behaviour?
Short answer, yes, there is that opportunity. A longer answer, some of the interactions between people movements are factored into the software parameters. So the agent-based simulation and agents will take into account the movements of other people around them, and then look ahead to things like congestion. There's other areas where there is an overlap, and that includes things like signage and wayfinding.
Good stuff. Could you say something about the application of the station modeling to destination stations? Example, major stations where dwell time is lengthened and encouraged by facilities such as destination retail as well as convenience retail. For example, St Pancras Station in London, if known to you, Martin.
Yeah, so we need to understand the activities that are happening within a station, either existing or planned. And for existing stations, understanding how people use the spaces and being able to validate that in a model before we can then go forth. And so once we've got the model validated and that behavior represented, we can then test changes to the station layout.
Thank you, Martin. A couple of questions for Louise. Video coverage is only as good as the quality of the equipment and often fails to enable identification of a person. All of this is after the event. Louise, what would a good system look like to you?
The most success I've noted at the bus station particularly, they had on-site security guards who did have, they were monitoring the surveillance systems actively, so they did have time to respond quite quickly if they noticed any events. So ideally, like I said, surveillance systems should be a supporting function of the built environment. Yeah. Yeah.
Good stuff. One of our commentators has asked, why are there transport facility and rebuilds occurring without CPTED analysis being undertaken? Christchurch bus station and Transform railway station are given as an example here.
Not entirely sure. I think it seems to be a cost component for the project, but ultimately it does become a cost component after the project is designed. So I'm currently working on a project where they've brought me in very early on, actually several projects where they're starting to bring us early on to do CPTED assessments, and we're finding issues within the design that you can fix quite early on, and then do a subsequent 80% design. So that seems to be working. I think the Christchurch bus station was a bit of an exception. It went up very quickly after the earthquakes, as it was just a quick response to getting the infrastructure moving around the city again.
Thanks, Louise. It kind of actually leads on to a question I had myself. So, what challenges do you find with CPTED making recommendations, and then those recommendations maybe not being aligned with a client's budget?
That's a tricky one. I think it helps to give the client options, as opposed to just telling them what is good and what is bad. Go back with solutions. But again, it's coming back really early on in the design process, identifying issues from the outset, as opposed to getting sort of 80% through your design and going, hold on a minute. And then you bring in different disciplines, which identify key problems, and then it creates rework. So like I said, bring in all of your disciplines early, identify, which will help identify any key features. But yeah, also reach out if you need any subject assessment done.
Thank you. Just one last question. What are good standards for lighting in areas leading into stations?
Good. I haven't specialized in lighting. I think that comes down to lighting designers. And again, just cross-checking that cross-checking your lighting designer with the landscape architect, for example, and then, your civil, just making sure that all of the disciplines are interacting, and that you don't have any visual impairments, or sorry, lighting impairments, lighting display impairments, through the introduction of I don't know, let's say buildings or trees, anything that could potentially impact that light display.
Excellent. I think that's all the questions we have. So I'd like to thank Martin and Louise for an excellent presentation. Yeah, reach out to both of them afterwards if you've got anything else you'd like to ask, and yeah, they're there for your CPTED needs. Thank you all for your time today. We look forward to seeing you at the next event in a couple of weeks. We've got a busy run of events before core, so yeah, make sure you register and join us, and we'll see you in core in August. Thank you very much.